This video is the continuation of our resonant electrical circuit project, in which we are researching the ability to take voltages and through resonance greatly amplify both the voltage and the power output to the end user. We have a signal generator here. We're taking our signal and running it into this box here. We have a series of transistors in our circuit in which the power supply positive is going here. We're switching it through our series of transistors. We're coming over here to this box right here, and we're outputting voltages from this through our circuitry into this box, and our multimeter here is measuring the output voltage which is running our generator. We'll zoom in a bit so we can watch our meters, and we'll begin the demonstration. As I turn the power up to the power supply, let's say 30 volts. The motor is running at about 25.5 volts, or at about a 4.5 volt deficit from the input power going into the box. If we increase our voltage to 50 volts, again, we see that we're inputting 50 volts into the frequency box and we're outputting 45, so we're still operating at about a 5 voltage point deficit. At 65 volts, our motor is running at 60.6 volts, and again the voltage range is about a 4.5 volt deficit from the input power going through the box. At around 75 volts inputted into the signal box, we're now seeing that our voltage deficit is decreased to a little bit over 1 volt, about 1.2 volts. So we're inputting 75 volts into the signal box. We're outputting about 73.6 to 73.7 volts. At around 80 volts, we hit a transition point to where now our voltage output is exceeding the voltage input going into the signal box. Through resonating the signal and going through the electronics, we're now outputting about 84.4, 84.3 volts. So we now have about a 4 volt surplus or increase from the input voltage to the output to the motor. As we increase our voltage, the voltage differential will even become wider. At 90 volts, our motor now is over 100 volts. So we've gone from about a 4.5 volt increase over the input voltage to a 10 volt increase over the input voltage. Now as we increase the input voltage, the spread or the differential of the output becomes greater and greater. We will now raise the input voltage to 100 volts. The voltage is still rising fairly rapidly from 100 volts input. We're now at 119 volts. About 119.2, 119.1. So our output voltage is fluctuating right around a 19 volt surplus from the input voltage. The disparity between the input and the output is becoming wider and wider. At 110 volts, we're now seeing our voltage rise quite rapidly going through the motor. Now our motor is running at 140 volts. So now we're seeing a 30 volt differential between the input voltage and the output voltage. The motor is running at 30 volts higher than the input of the voltage resonating the signal. You can pan over here and see our motor spinning away quite vigorously. Swing down here. We'll see our little box that's actually processing the signal coming out of the resonant frequency system. At 120 volts, now we're starting to really pick up the action. Our motor is running at about 44 volts higher at 164. So now the voltage differential from the input voltage to the output voltage is about 44.5 volts. So we're running at a 44.5 volt surplus. At 129 volts, our motor is now running at over 190 volts. Actually, we're right at 190. volts, so we're running at a 63 volt surplus. I'm purposely keeping the input voltage at this level because our electronics has an upper limit because of the way that we put this together at about 200 volts, and we would be going beyond capacity if we pushed the motor much higher than that. This can clearly be seen here. We're inputting 128 volts, we're outputting 190 volts, so we're running at 62 volts higher than the input voltage, which is about 50% gain. The motor is just spinning like a top. .5 volts. Now start powering the system down. Bring it to a point to where the input voltage and the output voltage is just about equal. Which is pretty close to around 75 volts. We see that at 75 it drops a little bit below. At 77 it's pretty close. And we'll go ahead and power it all the way down. And this concludes our demonstration.